Hey guys, welcome back to another of my videos. So in this one, we'll be looking at question 5 and we'll be tackling part A. Okay, so what do we have here? So we're given a figure where we can see that there's a curve intersecting with a straight line. And this curve is given by this y equation here for x greater than minus 2.5. Alright, so what do we know? So we know that the point P of x coordinate minus 2 lies on C. Okay, so we know this one has an x coordinate of minus 2. Let's just say minus 2 question mark. Okay, and that's literally what we're given, and we need to find an equation of the normal to C at point P. So the normal of the curve at point P, where we know x is minus 2, and this has to be written in this form. So the final form is no big deal. The whole point is understanding the equation of normal. So the first thing you want to do, of course, is find the equation of a tangent, and then after that use the perpendicular gradient, and you've done it. So let's do it. So first step is to write this form, y equals mx plus c. Okay. Next, then all we need is the perpendicular gradient. So what is the equation of normal at this point? So we know the x coordinate is minus 2. So I think it's best to find the value of y, right? So to find the value of y, all we do is plug in the x value into this equation here. So we're going to have y equals 2 log, and then plug in x minus 2 and get minus 4 plus 5, so log 1. So log 1 is actually 0. So this is actually pretty useful. Minus 3 times negative 2 over 2 would cancel out, and you're left with a positive 3, so it'll be plus 3. So therefore, the coordinates at P is going to be minus 2 and 3. Sweet. All right. Not so bad. Now, how to find the gradient? Okay. All right. So to find the gradient, actually, all we need to do is differentiate this equation, because remember, the gradient is the change in y with the change in x, which is the derivative of this. So let's find dy dx. So dy over dx, what's it going to be? Okay, so to differentiate the log function, all you have to do, so let's write the 2 first, constant. Differentiate the log function, you differentiate the inside and divide it by itself. So the derivative of 2x plus 5 is just 2, and then you divide it by 2x plus 5. That's literally all you do. Next, minus, and the derivative of 3x over 2 is just 3 over 2. Now plugging the value of x so we can get the actual gradient. So at x equals minus 2, the gradient m, so this is the regular gradient, the gradient for the tangent, not the normal. It's going to be 2 times, so this will simplify to make 4. So you can, just smash this in your calculator. You'll get negative 4 plus 5, this becomes a 1. So you get 4 minus 3 over 2. And then all you have to do from that point, so 4 minus 3 over 2, you should get 5 over 2, which is your tangent gradient. And then at this stage, finding the perpendicular gradient, you're just going to do the perpendicular. All you have to do is just find the reciprocal and flip the signs. So it's going to be minus 2 over 5. And voila, guys, plug all these values for m back in here, x and y back in here, and yeah, and then solve for c, and then all we have to do is just rearrange this. So therefore, plugging in all the coordinates, you're going to plug in 3 for y, so you get 3 equals m, the negative gradient, which is minus 2 over 5, times x, which is minus 2, plus c. Now solving for c, what should we get? So this becomes plus 4 over 5, so it'll be 3 take away 4 over 5, and this should give us a c value of 11 over 5. All right, cool. So I guess we're almost there. So now all we do at last is just plug in the grade. So now going back to the gradient equation. So let me just make a fresh page. Oops, don't need something like that. So what do we have so far? All right, so we have going back to y equals mx plus c. Therefore, our final equations be y equals the gradient, which we said was minus 2/5, and c is 11 over 5. Minus 2/5 x plus 11 over 5. Multiply the whole equation by 5 to get rid of the fraction. We're going to get 5y equals negative 2x plus 11. And finally, making it into ax plus by, plus in 2x to give us 2x plus 5y equals 11. And that's it, guys. Hope this video, and that's it, guys. So we're going to look at part B now, yeah? Alright guys, here we are, part B. So in this case, we need to show that the x coordinate of Q at this point here is the solution given by this. Okay, so in this case, we're not actually trying to find x, we're trying to present some kind of equation in terms of x. Because actually looking at this right now, you can't actually, it's quite difficult to solve without iteration methods. So what do we have here? So what do we know about Q? So we know that the curve and the line intersect both at points P and Q. So because they intersect, we know that the line equation can be simultaneously solved with the curve. So how about we substitute the curve into this equation here, yeah? So that'll be the first step. So that means, let's just start from here. We can say therefore 2x plus 5 multiplied by all of this would equal 11. So let's just simplify that all out. So we get 2x plus, now multiplying this by 5, what do we get? We're going to get 10 log bracket 2x plus 5 minus 15x over 2, and all of this equals the right hand side, which is 11. Now, just trying to match everything up, I think what the best way to do is to keep all the x terms on the left and the log x terms on the right. Okay, and then move, and then partition x. So let's clear the x terms. So we got 2x take away 15x over 2 will give us a negative 11x over 2. And subtracting 10 log x across, we're going to have 11 minus 10 log 2x plus 5. And just flipping the signs over actually, because we want this to be positive, don't we? So actually, no, first let's multiply by 2 and then divide by negative 11. So multiplying by 2 and dividing by 11, we're going to get x equals 22 minus 20 log bracket 2x plus 5. And then dividing by negative 11, we're going to have minus 11 here, minus 11. Therefore, x, just tighten this up, you can see that this becomes minus 2 and this becomes plus 20 over 11, just like we have here. So yeah, and therefore, just so now we're going to get exactly 20 over 11 log 2x plus 5, all subtracted by 2. And that's it, guys. That's pretty much what you have to do. And so yeah, so if you have any other questions, let me know. Otherwise, we're going to move on now. So see you in part C. Okay, part C, guys. So this one, oh my god, this is very easy. So let's have a look. So given that x1 equals 2, find the next two values using the iteration form below. So if you haven't seen iteration, all you literally do is just plug in, get a result, and then plug the answer to the next equation and get the third result. Easy, really, very easy. So what I did, I already found the solutions to this, but anyway, I'll just show you how it's done in case. So let's have a look. So to find x2, you literally just plug in x1 here. So we're going to get 20 over 11 times the log of 2 times x1, so x1 value is 2, plus 5 minus 2. And whatever the answer is, oh yeah, before you do this, I recommend that in your calculator right now, type the value 2, because x1 is 2, press the equal sign, and then this should be saved as your answer. And then when you type this formula, make sure you type it and just use the answer value. So here, so just type the answer button here. So every time you press equal, it will automatically generate the next answers without you typing the whole formula again. So yeah, when you put this in the calculator, you should get an answer of this, which I wrote, which is 1.9950. So x2 is about 1.9950, because basically I didn't write this in the question, but you need your answers to 4 decimal places. Now do the same for x3. So for x3, we're going to have 20 over 11 times the log of 2 times x2 plus 5 minus 2. And again, using your answer value, which should already be there, you just literally press equals again, and your answer for x3 should be 1.9929. And that's it. 929. That's really it, guys. Nothing more to iteration. You just plug and go. So anyway, I hope this video helped, and let me know if you've got any more problems to look at. Other than that, I shall see you guys soon, and take care. Ciao.